This demo presents the AI RAN blueprint, developed by zTouch Networks in partnership with RedHat. The blueprint offers repeatable testing and validation of AI RAN coexistence on shared GPU infrastructure. It is hosted on zTouch.OS, our AI RAN orchestrator, and lets you onboard and deploy workloads, monitor GPU utilization, and reconfigure its sharing policies. It is integrated with Keysight RU-Sim for repeatable experiments at scale, and includes a dashboard to observe workload execution and monitor KPMs, including throughput, CPU, and GPU utilization and power consumption. Our blueprint runs on OpenShift in a cluster with 3 NVIDIA GPU-equipped AI RAN nodes. Automation and orchestration is offered by zTouch.OS AI RAN orchestrator. Programmable UE and RU emulation comes from Keysight RU-Sim. We start with an example that shows how improper GPU sharing between RAN and AI workloads might result in resource contention and RAN outages. We consider a NVIDIA MIG partitioned GPU and use zTouch.OS dashboard to deploy a 5G GNB on the largest available GPU partition. We use the blueprint dashboard to monitor its deployment and execution status. We can open the GNB pod log shell and see that the GNB has been deployed correctly. We then use RU-Sim to benchmark GPU sharing policies and verify that the GNOD-B is connected. Once the GNOD-B connects to RU-Sim, we run a predefined emulation scenario, selected from a catalog of pre-configured scenarios that we use to evaluate sharing policies across different network configurations to validate AI RAN coexistence. Once we start the scenario, we use RU-Sim monitoring dashboard to verify that UEs are connected and generate traffic as specified in the predefined scenario configuration. We now deploy an AI training workload, ResNet for image recognition in our case, on the same GPU partition used by the GNOD-B. We notice that, although the training task starts successfully, the GNOD-B immediately loses synchronization and starts throwing errors, causing a full outage. We now demonstrate a more adequate GPU sharing policy that isolates the RAN and workload from AI training by assigning them to different GPU partitions. This enables safe AI RAN coexistence. We redeploy the GNOD-B and let it reconnect to RU-Sim, UES, connect, and generate traffic. We then deploy the AI training task on a different GPU partition from that being used by the GNOD-B. We then monitor the pod log prompt and verify it has started correctly. By monitoring all workloads, we notice that the GNOD-B continues serving UEs without interruption, while the AI training task executes as expected. This is the advantage of proper GPU sharing management and orchestration. Safe AI RAN coexistence is demonstrated by RU-Sim, confirming that all users remain connected and served. Once one or more experiments are complete, the blueprint generates a full summary of results. For a single experiment, you can visualize a wide range of KPMs, including throughput, error rate, and MCS, as well as GPU utilization across each GPU partition in real time. You can also load 2 or more experiments side by side to directly compare the impact of different GPU sharing policies. For example, you can overlay KPM curves and immediately see how sharing policies affected RAN performance. Thank you for your attention. Please don't hesitate to contact us with any questions.